Hello, good day my people. I hope each and everyone is cool, right? Okay, you are welcome to today's lesson. In today's lesson, we are going to be looking at addition and multiplication tables in a given modulo. Are we getting that? We have some tables that you'll be given to perform or to complete. You'll be asked to copy and complete. And that one, they are all in what? Modulo. So we are going to be looking at that. So whenever I'm giving those tables in modulo form, how am I supposed to do that? You see, I said addition and multiplication. So meaning here, we are not going to be speaking about what? Subtraction and what? Division. Are we getting that? We are only going to be tackling what? The addition and multiplication. That is all. Please, are we getting that? So there wouldn't be any case, a situation whereby you'll be giving what? Subtraction and division table for you to what? Perform. Please, are we getting that? Always you'll be giving addition and what? Multiplication tables. Please, are we here? Shall we proceed? So to do that, we are saying that the sum or product of two or more numbers in a given modulo is found by adding or multiplying the numbers before converting them into what? The given what? Modulo. You see, like we've been doing this once before. Yeah, we've been doing them before. So previously, that's what we were doing. Let's imagine you are giving, let's say, 8 plus 5 mod, let's say 5. This is what they are referring to. This one is the addition, the sum. Sum means what? We know it's addition, right? Okay, so the first thing you have to do is to what? Add these two numbers before you take the mode. That is what they are saying there. Please, are we getting that? So this one will be what? I think 13, then mode 5. And that one will get you, I know you're able to say it's what? 3. Okay, so that is that. That is all we are referring to. Sometimes you can be given, let's say, 5 times, let's say 10 in mode what? Let's say, or let me say 9. So when this one too is given, you have to multiply the 5 and the 10. Are we getting that? Or you have to multiply the 5 by the 10 first before taking the modulo. Are we okay? So this one will be what? 50 mod 9. And that one too is going to get us. So you put it on the calculator. We know normally we used to say what? The 50 over the 9, or 50 divided by 9, then we convert it. So we are having 5 full number, 5 for 9, and since what? The denominator of the mixed fraction is the same as that of the modulo, the remainder is what? 85. So we see 5. Please, are we getting that? So that is all that we are coming to be doing here. Are we okay? Okay. So that is all that we are coming to be doing. Are we getting that? So let's start with our first example under the multiplication and that of the addition. And this is what I want you to bear in mind. Sometimes in the question you'll be given what? Compute what? The addition and multiplication table for what? Modulo 4. Addition came before what? Multiplication. Sometimes you'll be asked what? Compute the multiplication table and also what? Addition table for what? Modulo, let's say the same 4. Are we getting that? And you have to begin with the operation that you were given first. Are we getting that? So here, what I just said, I said what? Compute the multiplication and what? Addition table for modulo 4. So we are going to compute that of the multiplication first before the addition. Please, are we getting that? Okay. So that is that. So if addition first, you do that one first. If multiplication first, you do that one first. Are we okay? Okay. So let's take our first example. So example number 1. And it says something. We have to draw an addition table and multiplication table for arithmetic modulo 5. So draw an addition and multiplication table for arithmetic modulo 5. Okay, so this is what we've been given, and even under that we have to do something. So then using your table, you have to evaluate I. 2 plus 4. I. 3 times 4. I. 2 plus 3 plus 4. IB 2 plus 4 plus 3 plus 4. Times 4. Then B, which is the last one. That is, so we put solution. Okay. So this is our first question, and in the addition, I put here this symbol, and that of multiplication, I put here this symbol. So in the table, whenever you are constructing, for addition table, you'll be seeing this symbol, and for the multiplication table, you'll be seeing what? This particular symbol as well. Are we getting that? Okay, so let's come back. We have to draw an addition and multiplication tables for arithmetic modulo 5. And in construction of the tables, we use what? Their remainders and constructing what? The table. So modulo 5, you know what the possible remainders for modulo 5 are what? I hope you are saying from 0 to where? 4, right? Okay, because we've done this already, right? Okay, so let me begin with that of the addition first. So I'll have the addition because they are saying addition and multiplication. So that one first. So that is the symbol over here. Then I write what? The possible remainders in the column and also what? Row form. Are we getting that? So I'll have 0, 1, 2, 3, 4, 5. Is 5 part of modulo 5 to be a remainder? No. Okay. So then 0, 1, 2, 3, 4. Okay. Then I have to do my lines. Okay. Okay. So that is done for the first one. So let's complete what? That of the addition before moving on to what? The multiplication. So what are we going to do now? We always take it what? Column by what? Row. Or somebody will say row by what? Column. So we take what? This row, then this what? Column. Are we getting that? So we are taking what? This one and this one. This against this. So we will get to a point that I will refer you towards this representing a certain letter and this one to representing what? Another letter. So we are taking it towards this one, then we take what? All the necessary words, rules. Are we getting that? So we are going to have 0 plus the 0. Then where they intersect, we put an answer. I think this one, the number basis with this one over there, right? So you know, or you are familiar with what we are doing now. So we have 0 plus what? 0 plus what? This 0, and it is getting you what? 0. Everything we are doing is in modulo what? 5. And we know 0 mode 5 is what? 0. So then 0 plus 1 is 1. Then mode 5, that one too is what? 1. So then 0 plus 2 is what? 2 in mode 5, which is 2. Then 0 plus 3 in mode 5, that is what? 3. 0 plus 4 in mode 5 is what? 4. Then we come to 1 plus what? 0. Please, you should not take the up by the down. Are we getting that? You shouldn't operate the up ones on the down ones, by the down ones on the up ones. Are we getting that? I mean the column ones on the row ones. Please, are we getting that? That is all that we are doing. So now I take the 1, I give it to all. 1 plus 0, which is what? 1. Then 1 plus 1, 2. Mode 5 is the same as 2. Because what? All these numbers are less than what? The modulo. You know that already. So then 1 plus 2, which is what? 3. 1 plus 3, which is 4. Then 1 plus 4, which is what? 5. And can we write 5 here? So 5 in mode 5 is what? We know it's 0, right? That is what? How many 5s can we get from this 5? 1 plus 4. Then you are saying what? 5. And what is left? 0. That is that. We have the 0 here. Then I take what? These 2. So 2 plus what? 0 is 2. 2 plus 1, 3. 2 plus 2, 4. 2 plus 3, 5. 2 plus 4, that is what? 6. So I'm having the 5 and the 6 here. Anything? The possible remainders for modulo 5, we don't have 5 and 6 inside. So please, as you are doing, you should be very, very what? Careful. Do we get that? So what do? I put here what? 0, and I put here what? 1. Because 2 plus 4 is what? 6. And 6 mode 5 is what? 1. And I think we know that, right? Okay. Okay. So that is that for this one. Then I take this one. So 0 plus this is what? 3 plus 0 is 3. 3 plus 1, 4. 3 plus 2, 5. So that one is 0. 3 plus 3, which is 6, and that is 1. 3 plus 4, that is 7. So 7 mode 5 is what? 2. Then 4. This one, okay, that's what? 5. So I'll write what? My 0. Then this plus this 6. So it will be 1. This plus this 7. So it will be what? 2. Then 4 plus 4, which is what? 8. So 8 mode 5 will get you what? 3. So meaning we will have only one set of 5 here. Then what is left? 3. That is that. So for the addition, that is that. And let's move on to that of what? The multiplication. So I'm going to have that of the multiplication here. So I'll put what? My times. The possible remainders are 0, 1, 2, 3, 4. 0, 1, 2, 3, then 4. So I construct. I rule my lines. Even if my lines are all that bad, I think you can straighten it, right? Using what? A ruler, right? Okay. So you shouldn't do as I'm doing, is it? It's horrible. Okay, let's proceed. So now, multiplication. So this one too, that is what? Product. So not this one by this, but rather this one by this. So I'll have 0 times 0, which is 0. 0 times 1, 0, 0 times 2, 0, 0 times 3, 0, 0 times 4, 0. Because 0 by any number is what? 0. So then 1 times 0 is also what? 0. 1 times 1, is that 1 to 0? No, 1 times 1 is what? 1. 1 times 2, 2. 1 times 3, 3. 1, 4, 4. Okay. Then I have that of what? 2 times 0, that one 2 is 0. 2 times 1, 2. 2 times 2, that is 4. Then 2 times 3, that is what? 6. And 6 in mode 5. The reason why I'm now referring to the mode 5 means what? The 6 is not part of the remainders of what? The modulo 5. So 6 in mode what? 5 is what? 1. I think you know that. Then I have 2 times what? 4, which is what? 2 times 4, which is 8. Then 8 in mode 5, that one is also getting you what? 3. Okay, then 3 times 0, 0, 3, 1, 3, 3, 2, the same thing, so 1, 3, 3, 9. So 9 in mode, or in modulo 5 is also what? 4. Then 3 times 4 is what? 3, 4, that is 12. So 12 in mode 5 2 is what? 2. Because we are going to have what? 2 sets of what? 5s here. Then what is left? That is 2. That is 5 times 2 is what? 10. Then subtracting the 10 from this, we get what? We get the 2. Or you can use what? The 12 divided by 5, then you use the least fraction as we've been doing. Okay, then I have 4 times 0, 0, 4 times 1, 4, 4 times 2, 8, so it will be 3, 4 times 3, 12, so it will be 2, then 4 times 4, which is what? 16. So 16 modulo 5, or 16 in mode 5 will get you what? 1. That is, we are going to have, you know this one already, I don't have to be speaking about this again. So that is that for what? The addition and multiplication what? Table. That is the first thing we were asked to do. We have to draw an addition and multiplication tables. 4. That is why they said what? Tables, because we are going to get 2. So these are the addition and multiplication tables for what? Modulo 5. What did we use in constructing the table? We used what? The possible remainders of what? The required what? Modulo. Are we getting that? Or the given what? Modulo. And we know this already, right? In constructing that. Then the follow-up questions are also saying that and this one is also saying, right after we are done, using your table. Let me put tables. Using your tables. A, evaluate. The first one is what? 2 plus 4. Some people used to say what? Plus. Whenever you're having the plus and the circle, you say what? Plus. So if you hear some people saying plus, it's the same as the plus. And can say the penalty. I know you people. Some people are even laughing at me. Hey, plus or plus is plus or what? Plus when it is having the circle. Are you getting that? Okay, let's proceed. Okay, so now I have the I. I says what? 2 plus or 2 what? Plus 4, which is equal to. Then let's see that one. So 2 plus 4. You don't have to use the calculator again in calculating that one. Some people will say what? Even given this, you can't just say what? 2 plus what? The ordinary 4, then you say 6. You are not supposed to do that again. Now we are using our table. So everything that we are doing is supposed to come from the table. Everything that we are doing is supposed to come from the table. So let's proceed. So we are saying that 2 plus 4 is giving us what? Then we come to the table. This is the addition, the plus table. This is that. So this is the 2 and this is the what? The 4. Where are they intersecting? That is what the answer there is what? 1. So here is what? 1. So you don't have to calculate for anything since you are using the table. Look into the table, check for the answer, then you come and put it. Please, are we getting that? Okay. So then I is also saying what? 3 times 4. And that one too. You see, because of the exam pressure, some people, you know, you are having this particular sign over here, and some people will be reading from here. Please, it's wrong. This is the addition, and this is what? The multiplication. So you come to that one. So that is the table 2, multiplication table. Then you check of that of 3 by what? The 4, they are intersection here. So the answer is what? 2 there. Then I, which is the third one, is also saying that that is this, that. So what do? We have the 2 plus, then into bracket 3 plus 4. So this one too is equal to. What do we do? You know, whenever you are given, let's say 2 plus 3 multiplying 3 or plus, let's say that, what do we do first? We first of all add what is inside the bracket before what? Adding the result to what? That is what? The law of odd mass, right? So the law of odd mass comes here. We solve what is inside the bracket first before doing the other ones. So I'm going to have what is equal to, then the 2 plus, are we getting that? These 2 has to stand on its own, then the plus, this one. What is this one getting you? You solve for this one first. So 3 plus what? The 4. We have the 3 plus the 4. So I come to the plus 3 plus what? The 4. And that one too is getting me what? 2. So already I'm having this. Then this is what I'm getting from this. Then I can say what? This one is equal to. Oh, let me bring this implies that. Oh, yes, so you can use the equal to. This is equal to this, which is also equal to what I'm going to give. Since I don't have space here, that is why I wrote it like this. But I think it will go there. I think it will go there. So that is what 2 plus 2. Then which is equal to. Then now you go and check that of this one. So I have what? The 2, then plus the 2. And that one gives us what? 4. So all that we are doing, if your table is wrong, definitely whatever you are doing there too is going to be what? Wrong. If you're able to get your table to be what? Correct. Everything you're going to do too will be what? Correct. Are you getting that? Okay. So let's move on to the IB. And the IB too says what? This, that. So I have 2 plus 4, then plus 3 times 4. And that one too is getting us well. So let's check for that one too. So bracket first. So I'll solve for this bracket and this bracket at the same time. So it's equal to this plus this. Already we solved it and we said it's what? 1. Some people will say maybe Kai, or I don't remember that. So you go back to the table. So 2 plus 4. 2 plus the 4, 1. Then that of 3 times 4 is what? 3 times 4. That one too is what? Is 2. That is what is here. So I'll have what? The 1 for this one, then plus the 2 for this one, and this one too will get us what? 1 plus 2 is getting us 3. And that is that. So I have what? Solving this bracket to get you this, plus that is what is here. Solving this bracket, that one to get you this. Then now we can take what? The operation on this. And we have what? That. Then the last one, which is the B, also says what? Where is it? That is this. And I think this one I can do. Can you try this one for me? Pause the video and do this one. And after solving, I hope you're able to get 3 times 2 plus 1 times 0, and we are saying it's equal to so 3 times 2 is getting us 3 times 2, that is 1. So I have my 1, then plus then 1 times 0, that is 1 times what? 0, and that is what? 0. And this one. So this is getting me this, and this is getting me that. I hope you're able to get that. Give me high five if you're able to get that. Oh, okay, that is good. Then now I take this one. So 1 plus what? The 0 is getting me what? 1. And I hope you're able to get this. Okay, that is good. That is good. Let's now proceed. So that is all under what? This particular example. So we now move on to what? Our second example. If any question, you give it to me in the comment section. Are we getting that? Okay. So example number 2 says, okay. So example number 2 says, I don't want lines. Thank you. So example number 2 says, draw an addition table for arithmetic modulo 6. Use your table to find I okay. So, in this particular example, we are to draw an addition table for arithmetic modulo what? 6. Are we getting that? So here we are doing that of only the addition. It's not always that we have to do that of what? Both the addition and what? Multiplication. Are we getting that? Sometimes we have to do only multiplication. Are we getting that? So you can see that the follow-up questions doesn't contain what? Or do not contain any of what? Multiplications inside. Are we getting that? Okay, so this one we are only going for okay, so in this one we are only doing for that of addition. Are we getting that? So we are doing for modulo 6. So what do we use in constructing the table? That is what? The possible what? Remainders. Are we getting that? And we know that of modulo 6, the remainders start from where to where? That is from 0 to 5, right? So we use that. So I have my solution there, then my plus here, 0, 1, 2, 3, 4, and my 5. 0, 1, 2, 3, 4, 4, and my 5. Let me make a small space and my 5. So I have it this way. I close it. Close this side too. Okay. Then I have this one going this way. Okay. So that is the table. So let's now what? Fill the table. So I have 0 plus 0, which is equal to 0. 0 plus 1, 1, 2, 3, 4, and 5. Because 0 plus anything is what? The same thing. Are we okay? Then I have that of 1 plus 0, which is what? Sorry. Which is 1. 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. This one will get us 5, and this one will get us 6. And we are in modulo what? Modulo 6. So here is supposed to be 0 because we have 6 mod 6 or 6 modulo 6 will get you what? 0. Are we getting that? Then you proceed 2 plus 0, 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, 2 plus 4, that is 6, so 0. 2 plus 5, which is 7, so it will be what? 1. In modulo 6 will be 1. Then 2 plus 3 plus 0, 3, 3 plus 1, 4, 3 plus 2, I have 5, 3 plus 3, 6, so it will be 0, 3 plus 3 plus 4, that is 7, so 1. 3 plus 5, that is what? 8. So 8 modulo 6 will get you what? 2. Are we getting that? So don't forget that you are working in what? Modulo. That is why we normally say what? Understanding the question is part of the exams. Are we getting that? Okay. So let's now proceed. So 4 plus 0, 2 is 4. 4 plus 1, 5. 4 plus 2, 6. So 0. 4 plus 3, 7. 1. 4 plus 4, 8. Which is what? 2. Then 4 plus 5, 9, which is what? 3. So that is 9 mod what? 6. Are you getting that? And that one will get you what? This 3. Let's now proceed. So I have that of 5, and this one will get me 5, 6, so 0, 7, 1, 8, 2, 9, 3, then 10, which is what? 4. That is 10 in modulo what? 6, and we'll get you what? 4. So that is that. You see, it's very simple. Okay, let's continue. So now we are done with what? The first part of the question, and we have to use what? Our table to find. That is why the question says use your table. So let's imagine what your table is wrong, and at long last you're able to get this ones correct. It's totally what? Wrong. Because you have to use your table. They didn't say use the table because your table must be different from what? Another person's what table. So if you get it with 3, 5, then this, please use your table. So a situation whereby you will not do the table, then you look at what your friends work to get the answers for the follow-up questions, they will mark you down because everything is supposed to come from your work, your table. And you are not having the tables, but you are not having the table, but you are having what? The answer. How then possible? Are we getting that? So you'll be marked down. So we are using our table. Do we get that? Okay. Let's proceed. Let's proceed. So now, using the table, that is we have to find I. 4 plus 4. And 4 plus 4 gets you what? That is from the table 4 plus 4. So we get what? 2. I says what? 2 plus 5 plus into bracket 5 plus 2, and that one too is equal to 2 plus 5. So 2 plus 5 is equal to 1, then plus, because we said bracket first. Then now 5 plus 2 is getting us 5 plus 2. That one too is getting us 1. Then 1 plus 1 plus 1 is getting us the 2. Are we getting that? So that is that for this one too. So let's move on to the third one, I. And that one says what? 4 plus k is equal to 0. So we have to find the value of k. 4 plus what number will get us 0? So this one is by what? Inspection from the table. We just do what? Inspection from the table. So 4 plus what number is going to get us 0? So we go to our table. Then we check. Here is the 4. Let's now check that of what? The 0. So 4 plus 0 is giving us what? 4, but not 0. 4 plus 1 is giving us 5. 4 plus 2 is giving us what? 0. So we can say 4 plus what? 2 is getting us what? 0. So let's proceed and see if we can get another number. So 4 plus 3, 1. 4 plus 4, 2. 4 plus 5, 3. So it's only 4 plus 2 that gets us what? 0. So we say what? We say what? 4 plus 2 is equal to 0. Then, therefore, k is equal to 2. Are we getting that? So, what did we do? 4 plus what number will get you 0? Then you go to a table, because we are using the table. Use your table to find the below. Then we verify that of what? This one. So we said what? 4 plus what number will get you k? And that is, we come here, this is the 4. Plus what number? So we are checking that on the top. So 4 plus 0 is getting us 4. 4 plus 1 is getting us 5. 4 plus 2 is getting us 0. 4 plus 3 is getting us 1. 4 plus 4 is getting us 2. 4 plus 5 is getting us what? 3. So it's only 4 plus 2 that is getting us what? The 0. So then we can say 4 plus 2 is equal to what? 0. Are we okay? Then we can say, now, since 4 plus 2 is equal to 0, then we can say what? K is what? 2, because this corresponds to that. Are we okay? So k is what? Definitely 2. So we have some situations whereby what? We just do what? A mere inspection. Are we getting that? Okay. So that is that for what? Example number 2. That is that for example number 2. So can we now move to example number 3? If no question. And even if there is question, you can ask me now. Okay. So example number 3. It says construct a table use the table to find I 4 times 2 I 3 times 1 times 5 times 2 I 1 times 4 times 5 times 5 times 2 times 4. IV says the truth set of n times n which is equal to n. So that is that. That is that. So what do we do now? We are to what? Construct a table for multiplication modulo says for the set that. You see, it's not all the times you'll be given what? Just the modulo and you'll be asked to just construct. Sometimes restrictions will be given. Are we getting that? Sometimes restrictions will be given. Like this one. Now they've chosen their set that you are to use to construct what? The modulo says. You see the possible remainders for modulo says start from where? 0 to where? 5. But now they are giving you this set from the remainders. They've picked these remainders for you to use in constructing the table. So if you see the question, you can't just what? Start from 0 to where? The 5. Are we getting that? This is the set given to you. Sometimes you can be given what? Only 2, 4. Sometimes you be given what? Let's say 1, 3, and then 5. And you have to do for that one alone. Are we getting that? If no restriction is given and you have to construct what? Multiplication table for modulo 6, that is when you will start from where? 0 to the 5. Are we getting that? So don't say that since they are having their set from 1 to 5, it's wrong or they are wrong that they didn't bring what the 0. That is the what set given to you. They can only choose to give you what, let's say 2 and 3 to be the set. And these are what? Subset of what? The possible remainders of what? Modulo 6. Are we getting that? So sometimes all that I mean is that they will choose for you what? The remainders to use in construction of what? The table. So always when the question is given, immediately you read and you get the module, please don't stop what? There. You have to now what? Proceed. So you get to what? Whether you are given what? A set inside, then you base on the set in constructing everything they are asking you to do. Are we getting that? So if you construct a situation whereby you start from 0, it means what? You are totally wrong. You deviated from the question. Use the set given to you. So always check if what? A set is given before you begin to construct the table. If no set is given, that is when you can do what? Construct for the modulo 6 using what? All the possible what? Remainders. Are we okay? Okay. So this one, what do we do? We have the multiplication symbol. Then I have the set. That is 1, 2, 3, 4, then 5. 1, 2, 3, 4, then what? 5. So I have this. So I have that. So that is that. Then now we start. So 1 times 1 is what? 1. 1 times 2, 2, 3. Then 4 and what? 5. 2 times 2, that is what? Sorry, 2 times 1, that is 2. 2 times 2, 4. 2 times 3, 6. We are in modulo 6. So it will be what? It will be what? 0. Then 2 times 4, that is 8. In modulo 6 is what? 2. So then we have 2 times 5, that is 10. In modulo 6 is what? 4. Are we getting that? So that is 10 modulo 6. And you know it's what? It's 4. Then let's now proceed. 3 times 1 is 3. 3 times 2, 6. In modulo 6 is 1. 0. Then 3 times 3 is 9. 9 modulo 6. And that is what? 3. Is it 3? 9 modulo 6. 3, 9 modulo 6. That is what? I have 3 here. Then we have that of 3 times 4. So 3, 4, that is what? 12. So 12 in modulo 6, 2 is what? 0. Then I have that of 3, 5, 15. 15 in modulo 6 is also giving you what? So we are going to have 2 groups of 6 and 3 will be left. So that is what? 3. Okay, so that is that for that one. Then let's proceed. Then I have that of what? 4 times 1 is 4. 4 to 8. Modulo 6 is what? 2. 4, 3, then 12. 12 in modulo 6 is what? 0. That is 12 in modulo 6. So we will have how many groups of 6 here? 2. Then nothing is left. Then we have 4, which is what? 16. So 16 in modulo 6. So if you don't know, you just put it on the calculator. 16 divided by what? 6. Then you get your answer. So I have 2 on our 2 on 3. 2 on 3. So the denominator is supposed to be what? 6 as the modulo. So now I multiply by 2, the top by 2. So I get what? 4. 4. Then 4, 5, that is what? 20. How many groups of 6 can I get here? So that is 4. That is 3, 18. So I'll be left with what? 2. Are we getting that? So I'll have 20 modulo 6 is what? I'll have 3 groups of what? 8. So 6, 6, 6, 6. Oh, I shouldn't do that. Then I have to say what? 20 divided by 6. So I'll have 20 divided by 6. Then conversion. So I have 1 over 3. 1 over 3, you multiply the denominator by 2, then the top 2 by 2. So you have what? 2. So 5 times 1, 2 is getting you 5. 5, 2 is getting us 10. 10 in modulo 6 is what? 4. 5, 3, 15. And we've done that one already. 15 in modulo 6 is what? 3. Then 5 for 20. That one is what we just did. That is 2. Then 5 times 5, which is what? 25. So 25 in modulo what? 6. I think it's 1. 25 divided by 6. So that one is 1. Okay. So now I think we are done with what? The table. That is that for the table. And now we have to do what? Use the table in finding. And I hope even you are done, right? Some people pause the video and be solved. And that is good of you. Are we getting that? In doing that. Okay. Now we say what? I say what? 4 times 2. So I'll have my 4. Then times what? My 2. Then 4 times 2 gives us what? 4 times 2 gives us what? I don't know. So 4, 2. I come to the table. 4 times 2. That is 2. Then I have that of the II 2 says 3 by 1. Then by 5 by 2. And that one too is getting that. So bracket first. So 3 by 1. 3 by 1 is what? 3. Then by 5 by 2 is what? 5 by 2, that is what? 4. Then lastly I have what? 3 by 4. 3 by 4 gets you 3 by 4. 3 by 4 gets us what? 0. 3 by 4 gets us what? 0. 3 by 4. 3 by 4. 3 by 4 gets us what? 0. Please, are we getting that? Okay. So if this is an answer, if we will say what? This is what? Not defined. It's not part of the what? Set. All that we are solving, we are supposed to get what? An answer that is part of what? The set or the remainders. I know 0 is part of the remainders, but since 0 is not part of the set given, now we say what? This one is undefined. It's undefined because what? It's not part of the set of the remainders given. Are we getting that? Or those that we use in the construction. 0 is not part. So we will get to a point as we are solving, we will be saying what? The 0 or some of the answers are not defined. When we say they are not defined, meaning what? The possible answers that we had are not part of what the remainders that we used. Please, are we getting that? We get there and you understand. Are we okay? So this is the answer for this. Are we okay? Then what are we supposed to do? We have the last one. You have to find the true set of this. So that is what? IB. And IB says what? N times N should be equal to what? N. So what does this one mean? It just means that a certain number multiplies itself to get itself. Because we have M multiplying M and the answer is still what? M. A certain number when multiplied by itself gets us what? The same what? Number. So now we go to the table, then we verify. Are we getting that? So let's see how to check for that one. What number multiplies itself to get you what? Itself. Are we okay? So what do? We can. So now we are checking the numbers multiplying themselves. So I have 1 multiplying itself and it is getting me what? 1. So 1 by 1 is getting me the same what? Number. Oh, good. So let's proceed. Maybe we are going to get more than 1. Let's take that of 2. So 2 multiplying 2 is getting us 4. That is wrong. It's not getting us the same 2. Or it's not getting us what? 2. Then I have that of 3. 3 multiplying 3 is getting us what? 3. You see, going further, now we are having another one. That's why you're not supposed to end. Immediately you get an answer in modulo. You have to proceed. You check for all. Are we okay? So now 3 by 3 is getting us what? 3. Let's proceed. So now we have what? 1 and 3. So we write our 1 somewhere, we write our 3 somewhere. Let's check that of 4. 4 times 4 is getting us 4. Oh, 4 is also what? 5. Then we have that of what? 5 times 5, and that one is getting us what? 1. So 1 times 1, 1. 3 times 3, 3. 4 times 4, and that one too is what? 4. So the values for n are, now we say what? I don't want to do it here. Let me do it here. Let me do it here. So now, so that is what? IB. We said n by m is equal to n. Now we are saying that 1 by 1 is equal to 1. Also, 3 by 3 is also equal to 3. And lastly what? 4 by 4 is also equal to 4. So therefore we can say that this implies that m is equal to what? 1 or 3 or 4. Or some people can also say that is equal to what? M is equal to 1 or m is equal to 3 or m is equal to 4. It depends on you. Whether to write m is equal to 1 or 3 or 4, or writing m is equal to 1 or m is equal to 3 or m is equal to 4, they are the same. So then we can now say what? Therefore, the true set is m is such that m is equal to what? 1 or 3 or 4. Are we okay? Or some people can also say that if they are using this one, then you see what? M is such that m is equal to 1 or m is equal to 3 or m is equal to 4. That is that. Please, are you getting that? They are all what? Correct. They are all correct. So now that is that. That is that for this particular set of example 2. So what I was emphasizing on is that It's not always that they say what, or they mention of a modulo, then you write all the possible remainders in constructing the table. I said sometimes they will choose a set for you. Are you getting that? They will choose some of the remainders for you to be used or to use in constructing what? The table. Are we okay? That is that. And if you're able to get that, everything is what? Very easy, isn't it? Voila. Okay. Let's continue. So we are now moving on to example number 4. Example number 4. So can I clean here? So example number 4. In example number 4, part of the questions will not be solved. I will just write only answers. Then you solve them and verify if you are going to get the same. You get your answers to be the same as the answers are right, meaning concept what? Develop. Okay. So example 4. And that one says, hey, draw and multiplication tables. For the set K is equal to 3, 6, 9, now 12. And in arithmetic modulo B from your table evaluate I say find the root set of n times n times plus 3 is equal to 3. Okay, so that is that. Then we put solution. Okay, so can you start? Yeah, pause the video and you start. So addition and multiplication tables for modulo 15, right? That is modulo 15. Then what do? So the first thing you have to do, whenever you read a question, underline the modulo. Are you getting that? So that as you are solving, you go to the question paper, the underline will what? Yeah, will cast you back to what? the modulo you are working in. Some people will just add and put what some answers for, forgetting that they are working in what modulo. Are we getting that? Okay. So I have my addition. Addition comes first before the multiplication. So I have, and for modulo 15 too, we were supposed to start from where? 0 to where? 14. Now they have picked what? Some of what? The remainders for you to do. So we are not going to do for, we are doing for the set given. Are we okay? So I have 3, 6, 9, then 12. 3, 6, 9, then 12. Then that of the multiplication to 3, 6, 9, then 12. 3, 6, 9, then 12. So it's supposed to go there. Then this one too. Then this way. Okay. So that is that. Let's now proceed. So 3 times 3, which is what? 9. Is it times? No. We are under what? Addition. So 3 plus 3, 3 plus 3, 3 plus 3 gives us what? Is it 6? Okay. 3 plus 6 is giving us 9. 3 plus 9 is giving us 12. Then 3 plus 12 is giving us 15. So we write what 0 because we are in modulo 15. Okay. Then 6 plus 3 is giving us 9. 6 plus 6 is giving us 12. 6 plus 9 is giving us what? 15. So 0. 6 plus 12 is giving us 18. 18 modulo 15 is what? 3. Okay. So 18 modulo 15 is 3. When you subtract 15 from 18, you get what? 3. Then I have 9 plus 6, which is what? 12. So I have my 12 here. 9 plus 6, which is 15. So I'll put my 0 here because 15 modulo 15 is 0. Then I have that of 9 plus 9, 18. 18 modulo 15 is what? 3. Then 9 plus 12 is what? 21. 21 modulo 15. Or you can subtract what? 15 from what? 21 and you're going to get what? 6. Or you can just put it on the calculator. 21 divided by 15. And that one is getting us 1 whole number 2 over 5. The modulo is what? 15. So the down is 5. We multiply the down by 3, the top by 3, and we'll get what? 6. You know that already. Then 12 plus 3 is 15. So 0. 12 plus 6, that is what? 18. So I'll put here 3. 12 plus 9 is what? 21. That is what we work. So 6. Then 12 plus 12 is what? 24. So 24 modulo what? 15. 24 modulo 15. And that one too is getting us what? Okay, 1 whole number 3 over 5. So what do? We multiply both the top by what? 3. So I will have what? 9. Okay, so I think that is that for the additions. Let's now come to that of the multiplication. 3, 3. So I put what? 9. If you don't know that, do you know what normally we sometimes also do? Okay, so to multiply this by that, to multiply this by this, and people will be using calculator, and how to convert will be what? Another word, this thing. Are you getting that? So what do? I can just put what? 3 times 3 on the calculator. So 3 times 3 on the calculator divided by what? Then the 15. I've put it down already because meaning what? I have 3 times 3 then divided by 15. What mass is what? Bracket of division. So it will take this one first before that. No. I want it to what? Do for this, then divide by what? The final answer. Are we getting that? So you can sometimes also put what? 3 times 3 in brackets, then divided by, are we getting that? So into brackets, 3 times 3, then divided by 15, and it is getting us what? 3 on 5. So the down is supposed to be what? The down is supposed to be what? 15. So multiply by 3, multiply the top 2 by 3, and here will get us what? The 9. Are we getting that? So it's what? 3. It was 3 over 5, so by 3 by 3. So we are having 9 on what? 15. So 9. Or 3 times 3 is what? 9. Is that not it? So that's the 9. So 3 times 6. 3 6, 18. That is it. Now 18 is what? More than that. So for you to put 3 times 6, 18, then you say divide by what? 15. You can do that. But for me to what? Move faster, I'm already having the division by 15 on the calculator. So that I will not always be putting divided by 15, divided by 15. I'll be keeping long. But yes, so if that's what you understand, you can do that. Are we getting that? Okay. So here, now I have the 3 times 3 on the calculator. Now I'm putting 3 times 6. So I'm going to change the second 3 to what? 6. So now I have what? 3 times what? 6. Click on the equal to, I have 6 over this thing, then I convert. I have one whole number, so the down is 5, I multiply by 3, the top 2 by 3, and this one gets me what? 3. That is why we said what? 3 times 6. 3 times 6 is what? 18. 18 modulo 15 is what? 3. Are we getting that? Then I have 3 times 9. 3 9, 27. Are we getting that? 27 modulo 15. So just change what? We are still on the 3. 3 times 9, so I'll have to change what? I have to change that of the 6 and make it what? 9. Then the division by 50 is still on the calculator. Because I'm not clicking on the on. I always what? Put my answer and then use the arrow keys. Are we getting that? Okay, so what do I do? I'll teach you, don't worry, right now. So 3 times 9. Now I'm putting the 3 times 9 divided by 15. I'm putting it, and it's getting me what? One whole number, 4 over 5. So they say 5 down, so by 3 by 3. So 4 times 3 is what? 12. I put here 12. Are we getting that? That is one whole number 4 over what? 5. You see, before watching today's lesson, you didn't make recap or you didn't revise on the previous ones. That is why you don't understand what I'm writing. Are you getting that? So anytime you want to watch a new video or something new you've not learned, what you have to do is what? Revise on the previous ones before what? Proceeding. Are we getting that? Don't just say, I've watched it already, understand. No, go back. You make sure what? You glance through before coming to what? This one. Are we getting that? Or the new ones? That is that. So this one, I put it on the calculator and it's getting me what? One whole number, 4 over what? 5. And now, here is supposed to be 15 because we are in modulo 15. So here by 3. Here by what? 3. So 3 4 is the 12. Are we getting that? Okay. I still have the thing on the calculator. Now I'm putting what? 3 times 12. So I'm only going to change this one to what? 12. I have this on the calculator. So I use my arrow keys. So I'll have what? Now I change the 9 to what? 12. So now I have 2 whole number 2 over 5. So by 3 is what? 6. So this one is getting me 6. I come here. 3 times 6 times 3. Now here is changing to what? 6. And here is changing to what? 3. So using the arrow keys on the calculator, yeah, I change this one to 6. And I change this one to what? 3. Then equal to the same thing. Or somebody can say 6 3 18, and that one too is what? 3. If you know that one 5, if you don't know, you put it on the calculator, and you're having what? One whole number 1 over 5. We are interested in the mixed the proper fraction. So what do? We multiply, you know that. I don't have to do that. Down by 3 by 3, and I'll get here to be the 3. Then I'm going to 6 times what? 6. So 6 times 6. So I have to change the second number, which is the 3 to what? 6. And I have that. And that one too is getting me 3, 3, so 6. Then 6 times 9. So I have my 6 times 9 by changing this one to what? 9. So you have that. So then the 9. So equal to then mixed fraction is what? I have 3 over 15 and 3 over 15, 3. So here will be what? 9. Are we getting that? Then I have that of what? This one 6 times 12. So I change the 9 to 12 using the arrow keys. So 12. Then equal to then my shift. So I have 4 over 5 and 4 over 5, 3. So 3 here, 3 here. So the down will be what? 4 times 3 is what? 12. Then I come to 9. So I'm going to change this one to what? 9, and this one will come to what? 3. So that is that. So 9, and I have 3. So then that one too is getting me, yeah, 4 and 5. So I'll have 3, so 3, 4. So this one gets me 12. Then I continue 9 times what? 6. So I change the second one to 6. Here will be 6. Then that one too is getting me 3 on 5. So by 3. 3, and here is getting me 9. Please, I think you are getting what I'm doing. Okay. Then I have that of 9 times 9, which is what? 18. Is it 18? Hey! That is what? I don't know. 81, right? Okay, but I don't know. You see, because of pressure, I said 18. What about you? That is why I said what? Everything we use the calculator. Even if it is what? 1 plus 1, put it on the calculator, you get your answer and you are good to go. Please, do we get that? Okay, so now when I put what? Here to be 9, so it will be 9 times 9, and somebody will say 81. Me, I don't want that. Put it on the calculator, so you change here to 9. So I have my 9, then it is getting me 2 over 5. So multiply the top by what? 3. So 2 times 3 is what? 6. Then I have 9 times 12. So I change to 12. Then I have okay, 1 over 5, 3. So I'll have here to be what? 3. Then this one now I have 12 times 3. So here we'll change to what? 12 on the calculator by what? 3. And the division is 3 because modulo 15. Are we getting that? So when you do this, 12 by 3, and that one too is getting us 2 on 5, and that is 2 times 3, and that is 6. So fill the remaining ones for me, and if you fill them, you should be able to get 6, 12, 3, 9. 12, 3, and 9. Are we getting that? So that is that. So you can use the calculator. And what some people can also were also doing is that they were saying that, let's say we want to calculate for this one. They were saying what? 12 times 6. Then they will say 12 times 6. 6. Then they will say divided by. They will put equal to. Then they say divided by. Okay. Then now they divide it by the modulo, which is the 15. Then they will have the answer. Then they do that. And the next one, if they want to do for 12 times 12, then they will say what? They will click on the AC again. Then they will say 12 times 12. Then equal to. Then divided by 15. Then they convert it. That one too is the same. But I see those having the 15 already on the calculator and they'll be changing this one will go faster. Are we getting that? So I'm not saying that if you do it 1, 1, 1, 1, you're going to get it to be wrong. You will get it to be correct, but you'll be wasting much time. So sometimes you have to learn how to use, you have to learn the tricks in using the calculator so that always you move faster in solving mathematics. Are we okay? Okay. So at long last, I hope you're able to get this ones. Okay. So now let's proceed. Then, so that is all this that we did. And for A, let's now move towards B. And sometimes I normally used to say that you write it here. Are we getting that? Write it in the middle. So we are on B. And on B, we are starting with the I. So you can't write in the I here. Some people will write what B-I. write the B here, underline, and come and write the I here. Or some people can even choose to write the B and the I here, and they proceed. So that one says you have to evaluate this, and this one also. I want to just put what? An answer. So after solving this, you should be able to get something like three. After solving, you should be able to get what? 3. Okay. Let me see by hands of those who are able to get a 3. Okay, that is that. That is that. So let's now move on to the second one, which is the II. And that one too says what? We are to find the true set of this. And in a case like this, we can also do it by inspection. Are we getting that? So we are going to take all the numbers. Why? Because I have this, that, then the answer, the same thing, and it should get me 3. So I don't know the number. You can inspect. Are you getting that? Some people can choose to just what? Do mere what? Inspection from the table. And here we are having both the what? Multiplication and addition being mixed. You can do that. Or some people can also choose to do what? Show all the workings. Are we getting that? So let's do mere inspection, then we come to what? Showing all the workings. We take what? 3, we take 6, we take 9, we take 12. Then we see through that which of them is getting us what? 3. Are we getting that? Are we okay? So let's take what? 3, and we are going to solve this side first. So let me first of all put this thing. N times n plus 3 is equal to what? 3. So let's now see. I'm now taking the first one, which is 3, and we are doing for what? Addition. So 3 plus 3, 3 plus 3 is getting us 6. Then that 6, you cross it with what? This one. Are we getting that? So now I'm going to have 6 here, and the number I picked is what? 3. So that is the 3 here. So here is 3, here is 3, because I picked what? The first number. So when n is 3, are we getting that? So I have what? The 3 here, the 3 here. Solving this is getting me 6. So now I'm going to have what? 3 times what? The 6. Okay, then the next one too is saying what? 6. So I have what? 6 to be here. So here will be what? 6. And here too will be 6. So I'll have here to be 6 and here to be what? 6. So you see that if you are not fast enough, you are not going to get the answer to be what? Correct. Are we getting that? So what do we do? That will be what? Very simple. This is what we are going to be doing. So picking the numbers, we are going to say what? When n is equal to what? 3. Then you put 3 inside this machine to check. Then you come to when n is equal to, so that what? Everything will be simple. Are we okay? So I'll have, this implies that I'll have 3 times, then 3 plus 3. And that one is equal to, solving this side will get you what? 3, then times, this side is getting me 3 plus 3, which is what? The 6. Which is equal to 3 times 6. Then we come to the multiplication one. 3 times 6 is getting us what? 3. So that is that. Are we getting that? So here, questions of this sort, don't just what? Inspect. But what are you supposed to do? To work it and see. Show all the workings. So we picked when what? We don't know the number. It could be this, it could be that. We don't know. So we are picking all the numbers. So we said what? When n is equal to 3, then we are putting 3 inside, or wherever we see n, we put what? 3. Then we are solving the bracket first as usual. So that one is getting us what? 6. So that is 3 plus 3, 6. That is what is here. Now I have what? 3 times, because that's the times here. 3 times what? The 6. And 3 times the 6 is getting us what? 3. And somebody will say, since now I have what? Oh, I need to be equal to 3, then that is all. Maybe 6, 9 or 12, one of them will also get us what? 3. So we have to do for or investigate for all before we conclude. Okay, then we'll pick the second one too. So picking the second one, that is what? When when n is equal to 6, then we have what? 6 times 6 plus 3. And this one is also getting me what? 6 times, then this plus this. 6 plus 3. 6 plus 3 is getting us 9. So I'm having my 9 here. Then which is equal to 6 times 9. 6 times what? 9. Which is 9, sorry. Which is 9. Are we okay? So then we do. So this one is not getting us what? The 3. When we take 6. So when what? N is equal to 9. Then this implies that we have what? 9 cross or plus 6 plus 6 plus then 9. Is it correct? Is it correct? It's not correct because n is 9. So then 9 plus our 3. So wherever I see n, I'm now putting what? The 9. So this one is equal to, I have the 9, then, the times. When I solve this, 9 plus 3 is getting us, 9 plus 3 is getting us 12. So this one will get us what? 12. And 9 times 12 is getting us what? 3. So you see 9, 2 has gotten us what? 9, 2 has gotten us what? 3. So meaning what? Now we are having 3 when n is equal to 3 and when n is equal to what? 9. Let's check for the last one. If that one 2 is going to get us what? 3. So lastly, when what? N is equal to what? 12. Then this implies that I will have what? 12 times into bracket 12 plus 3. And that one is getting me 12 times. Then 12 plus 3 is what? 12 plus 3 is 0. 0. So that is 0. Then 12 times 0. Do we have 12 times 0 here? We don't have 0 in the multiplication of what? In the multiplication table. Are we getting that? So it means what? This particular 12 times 0, and somebody will say is what? 0 is what? Not, or let's put what? It's equal to 0. And it's what? Not defined. It's an answer. We are having 12 times 0 and it's equal to 0 because for the multiplication table we are saying what? We are just multiplying. So this 12 times 0 is equal to 0. And this particular 0 or this 12 times 0, we have the 12 but we don't have 0 here. So we can't even say that it is getting us what? An answer because we are using our table. And using the table, 12 times 0 is not on the table here. So meaning what? Every answer we get for this is what? Not defined. And we are saying not defined because what? It is not part of the set. Are we getting that? It's not part of what? The set. Or the 0 here is not part of the set. Or when you check it from the table, 12 times 0. We don't have 12 times 0. 12 is here. We don't have that for the 0 here. And even if you take this 12, we don't have 0 here. So this one can't what? Work. That is why normally we say what? Undefined. So we give undefined for two conditions. Undefined, the first undefined is what? When the answer that we are getting is not part of the element of the set. Are we getting that? And second part is what? When the product or when the numbers we are operating, one of the numbers or all the numbers are not part of the element or cannot be located in the table or on the table, we say what? It is not what? Defined. Are we getting that? So meaning this one is even what? Out. So whenever you are giving what? This one to operate, we get our answer to be what? Undefined. So you can just be giving what? This one. Like right after the I, then I give you what? I. Then I give you here 12 times into bracket 12 plus 3 to solve. And if you solve and you get here, then you say what? Undefined. Even you are not supposed to even put what? This 0. You are not supposed to put the 0. Why? Because what? 12 times 0 from the table. Because from your table. Are we getting that? From your tables. When we check the table for multiplication, we don't have 12 times 0 on the table. So this one, straightforward, even here we put the undefined here or not defined here. Are we okay? So that is that. Then we say, this implies that our n is equal to what? 3 or what? 9. Because it's only what? 3 and 9. That gives us what? The 3 to be an answer. Are we okay? So we say therefore we are finding true set. So we say n is such that n is equal to 3 or 9. And that is that. Are we okay? So I think that is that for that. So whenever you are giving what? Modular tables to construct, please and please again, that is how they are done. There are about millions of examples in all the pamphlets, all mathematics pamphlets and other things. Please, you go for them, you solve them. I feel like A plus, all the words, pamphlets, they are inside, concise and other things, you get them inside. Go for them and solve. Are we okay? So that is that. So this is where I will end with you for addition and multiplication tables for a given modulo or in a given modulo. This is where we are ending. See you next time. Bye bye.